This Zoom session has been brought to you by the Fractal Fire. Okay, we do 5, 1, and 2. And we proceed. All right. Today we do 5-1, rules for exponents, and 5-2, x to a 0 power, x to a negative power. Okay, we start off with x to a power n. N will be a positive whole number. Later, like I said, we'll do 0 and negative powers, and somewhat after that, we'll do fractional powers. But anyhow, x to a power n. X is called the base, n is called the exponent or power. It equals, well, you start with 1 and you multiply by x n times. 1 times x times x times x times x times x times x n times. So for example, x to the first power is just x. X to a second power is x times x. It's also called x squared because if you have a square with side x, the area equals x times x, therefore x squared. X to the third power is x times x times x. It's called x cubed because if you have a cube with a side of x, then the volume is x to the third power, x cubed. X to the fourth power is x times x times x times x. I suppose, I mean, no one ever came up with a geometric term for it. I suppose you would call it x tesseracted if you believed in four-dimensional cubes. And of course, it goes on from there. 2. Now, if we have a second power times a third power, then that'll be x times x times x times x times x. That's 5 x's multiplied in a row. That's x to the fifth power. Now you get 5 from adding 2 and 3. X to the power 2 plus 3. This is a special case of the addition rule for exponents, which is that if you have multiplied 2 powers, then you add the powers. Now, x to the a times x to the b is x to the power a plus b. Now, if instead of multiplying a square times a cube, you take a square and cube that, then, okay, that will be x squared times x squared times x squared, 3 of them. And then you add the powers, x to the power 2 plus 2 plus 2, that's x to the sixth. I get a 6 from a 2 and a 3 by multiplying 2 times 3. This is a special case of the rule that x to a power a itself to a power b is x to a power a times b. Now, if you had a product and took, say, a second power of it, then that'll be xy times xy, and that's x times x times y. That's x to a second power times y to a second power. This is a special case of the rule that in power a of the product xy is a product of powers, x to the a times y to the a. Its powers distribute over multiplication the same way that multiplication distributes over addition. We won't be getting into logarithms this course, but when you take logarithms, this is basically the same as saying that multiplication distributes over addition. Excuse me, a little gray nuisance is a lot of phonetics and trees. Okay, out she goes, out the door. I close the door. I have her well trained, and she has me well trained. All right. If you have a ratio squared, x over y squared, that's x over y times x over y, that's xx over yy, which is x squared over y squared. And in general, a power of a ratio is a ratio of powers. X over y to a power a is x to the a divided by y to the a. Again, this is, so powers distribute over division in the same way that multiplication distributes over subtraction. Now, okay, that covers some of the rules, the basic rules of positive powers. However, we're going to define 0 powers and negative powers. To do that, we use a general rule. Here's the idea. X to any power n, will be x to the power n minus 1 plus 1. And this addition turns into x to the n minus 1 times x. So if you divide through by x, then x to the n divided by x is x to the power n minus 1. So if you subtract 1 from a power, that's taking the original power divided by x. We'll use that rule to define x to the power 0 and power negative. For example, x to the power 0 is x to the 1 minus 1. That'll be x to the 1 minus x. That's x over x is 1. So 0th powers in general equal 1. X to the negative 1, that's x to the 0 minus 1. That's x to the 0 over x. That's 1 over x. X to the negative 2. That's negative 1 minus 1. That's x to the negative 1 over x. That's 1 over x divided by x. That's 1 over x squared. And so on indefinitely. Basically, this means that the 0th power equals 1 in general. And x to a negative n power is 1 over x to the n. So a negative power is the reciprocal of a positive power. It's basically you take 1, you divide by x n times. Now, since x to the n and x to the negative n are reciprocals, it works the other way as well. 1 over x to the n is x to the n. And if you have a ratio of negative powers, then you can put this in x to the negative, this in the denominator as x to the m. And you put this y to the negative n in the numerator as y to the n. So x and y switch places when their powers change sign. Now we can use this to define general ratios of powers. For example, we'll take x squared over y to the 5th, x squared over x squared, and x to the 5th over y squared. X squared over y to the 5th, that's 2 x's divided by 5 x's. Cancel 2 of them, you get 1 over 3 x's. That's 1 over x to the 3rd, that's x to the negative 3. We get negative 3 from 2 and 5 by subtracting x to the power 2 minus 5. X squared over x squared, that's 1, which is x to the 0. That's x to the power 2 minus 2. So again, we subtract the powers. X to the 5th over x squared, that's 5 x's divided by 2 x's. 2 of them cancel, leaving 3 x's, x to the 3rd. And again, that's 5 minus 2. Subtract the powers. In general, a ratio of powers, x to the a over x to the b equals x to the difference of powers, x to the power a minus b. All right, now we have some examples. I'm going to do some examples from 5.1, and then we'll do some examples from 5.2. So we have negative 4 t, 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 t. That's 1, 2, 3, 4, 5 t's. So that's negative 4 t to the 5th. B times b squared times b cubed. Now, you have to be careful here because people do make this mistake. They see nothing up here, and so they write b to the 0. That's not true. B equals b to the 1st. So really, we should write this b to the 1 times b to the 2 times b to the 3. So we have b to the sum, 1 plus 2 plus 3. That's b to the power 6. A squared b cubed times a cubed b cubed. Well, we have a squared a cubed here, b cubed here. Add the powers here, a to 2 plus 3. Add the powers here, b to 3 plus 3. That's a to the 5, b to the 6th. Here we have a ratio, c to the 3rd, d to the 7th over cd. Now, once again, we have to be careful here. There's nothing in these powers, but that means first power. C to the 3rd over c to the 1st, d to the 7th over d to the 1st. So we subtract c to the 3 minus 1, d to the 7 minus 1. That's c to the 2nd, d to the 6th. Now here we have y to the 3rd, y to the 4th over y to the 2nd. Again, we have to take care to write this y as y to the 1st. We add the 3 and the 4 in the numerator, that's y to the 7th. We add the 1 and the 3 in the denominator, that's y to the 4th. Y to the 7 over y to the 4th, we subtract y to the 7 minus 4, that's y to the 3rd power. All right. M to the 50th to the 10th power. Now this is not m to the 50th times m to the 10th. It's m to the 50th itself to the 10th. And iterated powers, we multiply the powers. M to the 50 times 10, it's m to the 500. Here we have a power or product of powers. Okay, first x squared y cubed all to the 5th. First we combine these in the middle. X to the power 2 plus 3.
I'm sorry, Professor, Doctor.
Yeah.
On number 55, is that times -10?
No, that's times 10.
Okay, all right,
Measure the other times a little awkward. Perhaps I should change that just a moment.
all right. Thank you. Yeah.
5, 6, number 55, m to the 50 times 10, not negative. Thank you for asking. All right, here we go. We're up here. We had x to the 5th to the 5th. So you multiply them. I hope you can read that 5. Maybe I should change that as well. And that's x to the 25. Now here we have a product of powers of powers. Okay, u to the 4 times 2 times u to the 3 times 2. Here we go. 4 times 2. Oh dear, is that a 3? This should be a 3. Oh dear, dear, dear me. Honk. That was a mistake. 65. U to the 4 to the 3. All right. 4 times 3, that's a 12. 3 times 2, that's a 6. Add 12 and 6, you get u to the power 18. I'm sorry, that was a mistake. I have to change that. Here we go. Now, r to the 4th, s to the 3rd, all to the 4th, over r to the 3, s to the 9. What's that? Okay, first we distribute the 4th power over this product. R to the 4th to the 4th, s cubed to the 4th, over r cubed s 9th. All right, so here we multiply the powers, r to the 4 times 4. Here we multiply the powers, r to the 3 times 4. That's r to the 16th, s to the 12th. For the r, we subtract 16 and 3, 16 minus 3. For s, we take the power at 12 minus 9. That'll be r to the 13th, s to the 3rd. CD to the 4th times CD. Well, again, these are all first powers. We have to take care to put those ones there and there. All right, c to the 1, c to the 1, that's c to the 1 plus 1, which is c squared. D to the 1, d to the 4, that's d to the 4 plus 1, that's d to the 5th. So c squared, d to the 5th. A to the 2, b to the 2, all to the 15th, over ab to the 9th. So we distribute the 15th power in the numerator, distribute the 9th power in the denominator. A to the 2 to the 15th, b to the 2 to the 15th, a to the 9th, b to the 9th. Here we multiply 2 times 15, you get a to the 30th. Here we multiply 2 times 15, you get b to the 30th. For a to the 9, b to the 9, so we subtract powers. A to the 30 minus 9, b to the 30 minus 9. So that's a to the 21, b to the 21. N to the 4th, n cubed 6th is what? All right. Okay, here I'll distribute 3 over these powers. The power 3 over these factors. N to the 4th cubed times n cubed. Here we multiply the powers into the 3 times 6. And we'll multiply these into the 4 times 3 times into the 3rd times into the 18th. This is a 12. N to the 12, n to the 3, n to the 18th. We add those powers, 12 plus 3 plus 18 is 33. And result, n to the power 33. All right, here we have one of those look-alike problems, not 119 ABC. Here we have a 3rd, a 2nd, and a 4th power being differently applied to all these b's. B to the 3, B to the 2, B to the 4, they're all multiplied, so we just add them, 3 plus 2 plus 4, which makes 9, so the result is b to the 9th. Here I have b to the third, b to the second, that to the fourth power. So we start by adding in the 3 and the 2, b to the 3 plus 2 to the fourth. That's b to the fifth to the fourth. Multiply 5 times 4 and get b to the 20th power. Have b to the third, b to the second over b to the fourth here. Okay, we add the powers in the numerator, b to the 3 plus 2 over b to the fourth. That's b to the fifth over b to the fourth. Subtract the powers, 5 minus 4 makes 1, b to the 1, and that's the same as b. All right, now we skip on to 5(2), and finally we get to take ratios of powers where they're negative. Y to the 8th, y to the negative 2, we add 8 plus negative 2 and get y to the 6th. Y to the 4th over y to the 5th, that's y to the 4 minus 5 is y to the negative 1. And the book wants you to write everything either in positive powers, so this is 1 over y. H to the negative 5 over h to the second. Negative 5 minus 2 of the powers, that's negative 7, h to the negative 7. And again, we write it all in positive powers as 1 over h to the 7. X to the fourth to the negative third is what? You multiply 4 times negative 3, x to the negative 12, and we rewrite that as 1 over x to the power 12. All right. 6, s to the fourth, t to the negative 7th, all to the second power. Okay, take this slow and easy. Second power of each of these factors. 6 to the second, x to the fourth to the second, t to the negative 7 to the second. 6 squared is 36. Here we multiply 4 times 2. Here we multiply negative 7 times 2. We get 36, s to the 8th, t to the negative 14. And we write the t to the negative 14 in the denominator and get 36x s to the 8th over t to the 14. Here, 2 to the negative 1, a4, b2 over 3 to the negative 2, a to the second, b to the fourth. Well, first thing we'll do is we'll do that swap rule that I mentioned a few pages back, where these swap places in the fraction because of the negative sign, negative powers. They wind up with 3 to the second in the numerator and 2 to the first in the denominator. The rest the same. 3 to the second is 9, 2 to the first is 2, 9 happens. Now here we'll subtract powers of a, here we subtract powers of b. A to the 4 minus 2 times b to the 2 minus 4. That'll be 9 halves a squared b to the negative 2. A squared goes in the numerator, b squared goes into the denominator. 9a squared over 2b squared. There. Here's this gnarly thing. Y to the third, z to the negative 2 over y to the negative 4, z to the third, all that to the second power. Okay, first let's work this out. Ratios of y's means we subtract the powers. Y to the 3 minus negative 4. Same with z, z to the negative 2 minus 3. Here, all squared. Now 3 minus negative 4 is 3 plus 4 is 7. Y to the 7. Negative 2 minus 3 is a negative 5. Z to the negative 5. All squared. We distribute the second power over each factor. Y to the 7th squared. Z to the negative 5th squared. We multiply the powers. 7 times 2 is 14. Negative 5 times 2 is negative 10. Y to the 14th. Z to the negative 10. Although I suppose I could put one more step. Y to the 14th divided by z to the plus 10. Now here is a trickster one. A to the second, b to the third over a, b to the fourth. They're tempting you to go to all this trouble, writing out all this, and then take it to the 0th power. But anything to a 0th power is 1, so you can do that in one step and avoid a lot of diversionary steps. Here we have 9 to the negative 2, x to the s to the 6th t, over 4 to the negative 3, s to the 4th t to the 5th. Okay, these negative powers swap from 9 to the negative 2 in the numerator to 9 squared in the denominator, 4 to the negative 3 in the denominator to 4 to the 3 in the numerator. This t we'll write as t to the first. So 4 cubed, 4 times 4 times 4 is 64. 9 squared, 9 times 9 is 81. 64 over 81. We subtract the powers of s, 6 minus 4. We subtract the powers of t, 1 minus 5. So 64 over 81, s to the second, t to the negative 4. And again, okay, we'll write this as a negative, this as a t to the fourth in the denominator. So you get 64s squared over 81t to the fourth. Now here we have the fifth power of 2x to the third y to the negative 2. Okay, we distribute the fifth power over each factor. 2 to the fifth, x cubed to the fifth, y to the negative second to the fifth. 2 to the fifth is 2 times 2 times 2 times 2 times 2. I've memorized the powers of 2. I find it useful. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. It comes in handy from time to time. Pardon the pun. Oh, and by the way, I grew up in the Boston area, and there's a nearly circular highway around Boston. It, of course, ends at the Atlantic Ocean. And it's called Route 128, and it's the equivalent of Silicon Valley here near San Francisco. Route 128 is where all the tech companies decided to set up shop. I find it mildly amusing that they all chose to build on Route 2 to the 7th power. Anyhow, so 2 to the 5th, that's 32. Here we multiply. Yes?
Excuse me. Just so I can see a tendency, and I just want to be absolutely sure. For instance, on the 91st, first problem. So whenever we are solving a problem, we don't want to leave any negative exponents, right?
I tolerate
Is that?
But the book.
I'm asking because I would have thought that if the problem was already solved when if you left it as 64s squared t minus 4 over 81.
That's doable too. I mean, I tolerate that. I'd accept that. So okay, you consider this a correct answer, and this is a correct answer, but that for just a hair more. That's all. Let us proceed.
Understood. Thank you.
Y cubed to the 5th, you multiply the powers, 3 times 5. Y to the negative 7th, second to the 5th, multiply those powers, negative 2 times 5. Get 32. X to the 15th, y to the negative 10. And yes, this is acceptable as an answer, but you can also put the y to the 10th in the denominator. 32x to the 15th, y to the 10th, also an acceptable answer. 123 is another one of these lookalike problems because we have a 4, an x, a y, and a negative second power thrown around randomly. Here's 4x to the xy to the negative 2. Well, this one, yeah, they are asking for writing only in positive powers. So here we write 4x over y squared. The second power is in the denominator for y. Here's 4xy to the negative 2. What's that? The whole thing to the negative 2. Well, that's 1 over a whole thing to the second power. Distribute the 2, the second power, get 4 squared y squared x squared over, no, it's the same as 1 over 16 x squared y squared. There. Here's 4x to the negative 2y. What's that? Well, I'll write this as an x to the second in the denominator and get 4y over x squared. So these are very similar. A and C. Then there's 4 to the negative 2xy. What's that? Well, that's xy over 4 to the second. That's xy over 16. believe we're done. So let's stop